Exactly when we contemplate stars, we habitually imagine little gleaming concentrations in the night sky. This is the manner in which we see them from Earth. However, stars like Betelgeuse are totally unique. Truly, Betelgeuse is titanic, to the point that it is far bigger than our Sun. For a really long time, this star has perplexed analysts. Lately, however, something considerably more agitating has been happening with Betelgeuse, causing worry among specialists and experts alike. In this video, we dive into the amazing reports regarding Betelgeuse, including its potential destruction as observed by the James Webb Space Telescope. We'll also explore what these developments could mean for our galaxy and life on Earth, as explained by physicist Michio Kaku. Betelgeuse is an incredible marvel, a colossal star that has fascinated astronomers for a very long time. The initial discovery of this star came from the Greek astronomer Ptolemy. This star is so enormous that it can be seen in the night sky from Earth, particularly throughout the colder months. If you have an enthusiasm for astronomy, you've probably seen or heard about it. Betelgeuse is the dazzling, reddish-orange star that marks the upper left shoulder of the Orion constellation. It is an ancient star, one of the most luminous in the night sky. However, its brightness is not constant, it fluctuates. This variability is one of Betelgeuse's most fascinating characteristics, but it's not the only unique feature. The unusual characteristics of Betelgeuse. Most of the stars we see at night are incredibly distant from our planet. The closest one, Proxima Centauri, is 4.2 light-years away. To understand what a light-year means in terms of distance, imagine traveling at the speed of light, 186,000 miles per second, for an entire year. The total distance light covers in a year amounts to 1 light-year, which equals billions of miles. So, when we say Proxima Centauri is 4.2 light-years away, it means it is billions of miles from Earth. Some stars, like Betelgeuse, are significantly farther. Betelgeuse is approximately 600 light-years from Earth. This means that even if we could travel at the speed of light, it would take us 600 years to reach it. Unfortunately, we can't travel that fast, not even with our fastest spacecraft. Still, Betelgeuse shines brightly in our sky despite its vast distance. If you're wondering how Betelgeuse can be so bright from so far away, the answer lies in its extraordinary characteristics, its massive size and intrinsic luminosity. Betelgeuse is more than 1,000 times larger than the Sun, and its radius is believed to be several hundred times that of the Sun. When viewed with advanced telescopes, it appears as a disk rather than a small point of light, unlike most other stars. This phenomenon is believed to be caused by reactions occurring in its outer layers. In terms of mass, Betelgeuse weighs somewhere between 12 and 20 times the mass of the Sun. One solar mass is equivalent to 2 times 10 superscript 3 kilograms. However, astronomers can't pinpoint the exact mass of Betelgeuse because there are no planets or bodies orbiting it for comparison, making direct measurement from Earth impossible. What makes Betelgeuse so exceptional is that it is significantly more massive than our Sun. The star's brightness ranges from an apparent magnitude of plus 0.0 to plus 1.6. In simpler terms, Betelgeuse is over 100,000 times more luminous than our Sun, earning it the nickname Red Supergiant. However, its brightness is not stable, it fluctuates. These variations are caused by the star's pulsations. When Betelgeuse expands, it becomes brighter. When it contracts, it dims. These cycles can last anywhere from 10 to 100 days or even longer. Magnetic spots and surface activity. One fascinating aspect of Betelgeuse is that its surface contains dark magnetic spots, regions where the magnetic field is significantly stronger than the surrounding surface. These spots hinder the flow of hot gases, cooling those areas. Betelgeuse has far more of these spots compared to our Sun, which explains why it is cooler despite its greater size and brightness. While our Sun also has dark magnetic spots, Betelgeuse's spots are much larger and more numerous. To give you a sense of scale, some of these spots can be twice as large as Earth. Betelgeuse also has a magnetic field that is many times stronger than the Sun's. This magnetic field is responsible for the arc-like patterns that appear on its surface when viewed through a telescope. The surface temperature of Betelgeuse is around 3,500 Kelvin, contributing to its lower energy output and dim red color. However, Betelgeuse wasn't always a red star. About 10 million years ago, Betelgeuse had a yellowish tint, similar to our Sun. Over time, its color shifted to orange and then red. About 1 million years ago, it began transforming into the red supergiant we see today. This change led scientists to conclude that Betelgeuse is aging. Betelgeuse emits up to 100,000 times more energy than our Sun. If it were closer to Earth, it would outshine the Sun. If it were even slightly nearer, we might be able to see it during the day. However, due to its enormous size, if Betelgeuse replaced the Sun, it would engulf Earth and nearby planets. Even if it somehow matched the Sun's energy output, it would still radiate significantly more energy, making it vastly more powerful than our Sun. Despite being 600 light-years away, Betelgeuse is still visible to the naked eye, which is extraordinary. The future of Betelgeuse, a star approaching its end. Betelgeuse is a red supergiant, a stage in a star's life that signals it is nearing the final phases of its evolution. As a massive star, it won't fade away quietly like our Sun. Instead, Betelgeuse is expected to go out with a spectacular supernova explosion, one of the most powerful events in the universe. Will Betelgeuse explode soon? For years, astronomers have speculated about when Betelgeuse will reach the end of its life. Supergiant stars like Betelgeuse burn through their nuclear fuel rapidly, meaning their lifespans are relatively short in cosmic terms, just a few million years compared to the Sun's billions. In late 2019 and early 2020, Betelgeuse experienced a mysterious dimming event, leading many to wonder if it was about to explode. For months, the star's brightness dropped to nearly half its usual level, an event unprecedented in recorded history. Scientists later discovered that this dimming was caused by a massive ejection of dust and gas, partially obscuring our view of the star. While this event was not the prelude to a supernova, it showed that Betelgeuse is undergoing massive changes. Astrophysicists predict that Betelgeuse will explode within the next 100,000 years, a blink of an eye in cosmic time. However, determining exactly when this will happen is challenging, as we are still learning about the internal processes of dying supergiants. What will happen when Betelgeuse explodes? When Betelgeuse finally goes supernova, it will be a breathtaking event. The explosion will release an immense amount of energy, temporarily making it as bright as a full moon. The supernova will be visible during the daytime and could shine in the night sky for weeks or even years before fading. Despite its relatively close distance of 600 light-years, Betelgeuse's explosion poses no direct threat to Earth. Astronomers have determined that it is too far away for the impact to cause harm. However, the supernova will provide valuable scientific insights into stellar death, allowing astronomers to study the formation of neutron stars or even black holes. Observations by the James Webb Space Telescope. The James Webb Space Telescope, JWST, has been closely monitoring Betelgeuse, providing unprecedented details about its surface activity and structural changes. By analyzing infrared radiation, JWST offers a deeper understanding of this extraordinary star's fate. The James Webb Space Telescope's observations. The James Webb Space Telescope, JWST, has been closely monitoring Betelgeuse, providing unprecedented details about its surface activity and structural changes. By analyzing infrared radiation, JWST allows astronomers to peer into the star's outer layers, detecting temperature shifts, gas movements, and large-scale eruptions that may signal the final stages of its life cycle. One of JWST's most remarkable discoveries is the detection of massive convective cells on Betelgeuse's surface, giant bubbles of hot gas rising and falling within the star. These convective cells contribute to the star's unpredictable brightness variations and occasional dimming events. In late 2019 and early 2020, Betelgeuse experienced a historic dimming event, during which it lost nearly 50% of its brightness. Initially, many astronomers thought this might be the precursor to a supernova. However, JWST and other telescopes later confirmed that the dimming was caused by an enormous ejection of dust and gas, which temporarily obscured our view of the star. Interestingly, JWST has also detected intense infrared emissions from Betelgeuse's outer atmosphere, suggesting that the star is shedding significant amounts of material into space. This mass loss could be a crucial step toward its eventual collapse and explosion as a supernova. How will Betelgeuse explode? When Betelgeuse finally reaches the end of its life, it will undergo a core collapse supernova, type 2P. This process occurs when a massive star exhausts its nuclear fuel, causing its core to collapse under the force of gravity. This collapse triggers an enormous rebound explosion, releasing an unimaginable amount of energy. Here's what scientists predict will happen during Betelgeuse's supernova. 1. Core collapse. The star's core, no longer supported by nuclear fusion, will collapse under its own weight, forming either a neutron star or, if massive enough, a black hole. 2. Shockwave rebound. The sudden collapse will generate a powerful shockwave that will tear through the outer layers of the star, blasting material into space at incredible speeds. 3. Blinding brightness. For a few weeks, Betelgeuse will be as bright as a full moon, making it visible even during the daytime. It will outshine every other star in the night sky. 4. Nebula formation. Over time, the ejected material will expand and cool, creating a supernova remnant, a beautiful nebula similar to the Crab Nebula, the remains of a star that exploded in 1054 AD. Will the supernova affect Earth? Despite its relatively close distance of 600 light-years, Betelgeuse's explosion will pose no direct threat to Earth. Scientists have determined that for a supernova to cause harm, it would need to be within 50 light-years of our planet. However, Betelgeuse's supernova will still have important indirect effects. An incredible celestial event. Humanity will witness one of the most spectacular cosmic phenomena, a nearby star explosion visible for months or even years. Ancient civilizations recorded past supernovae, and Betelgeuse's explosion could be one of the most well-documented in history. Cosmic ray burst. The explosion will release a powerful burst of cosmic rays and gamma radiation, but at 600 light-years away, these high-energy particles will not be strong enough to significantly impact Earth's atmosphere. A new nebula in the sky. The remnants of Betelgeuse will eventually form a glowing nebula, which could be visible for thousands of years. Future astronomers may study this nebula to understand the life cycles of stars. What comes after Betelgeuse? Once Betelgeuse explodes, it will leave behind either a neutron star or a black hole, depending on the mass of its core. If the remaining core is less than 3 solar masses, it will compress into a neutron star, a superdense object only 10 to 15 miles across but packed with the mass of the Sun. If the core is heavier, gravity will pull it into a singularity, forming a black hole. Interestingly, the Orion constellation will look different once Betelgeuse is gone. For millennia, this red giant has marked Orion's left shoulder, but after its supernova, Orion's familiar pattern will change forever. The legacy of Betelgeuse. Betelgeuse's imminent supernova offers an extraordinary opportunity for astronomers. With modern telescopes like JWST, Hubble, and ground-based observatories, scientists will be able to study a supernova in real time, something that has never been done before for a nearby star. Observing Betelgeuse's explosion will provide critical insights into the final stages of massive star evolution, the formation of heavy elements, like iron, gold, and uranium, in supernovae, the birth of neutron stars and black holes, the impact of supernova explosions on interstellar environments. In many ways, Betelgeuse is a time capsule of stellar evolution. It is a dying giant, offering us a front-row seat to one of the most powerful natural events in the universe. Conclusion: the countdown to an epic event. While Betelgeuse's exact explosion date remains unknown, astronomers agree that it is cosmically imminent. It could happen tomorrow, or it could take another 100,000 years. However, whenever it does occur, it will be an unparalleled spectacle, visible to the entire world. Thanks to the James Webb Space Telescope and other cutting-edge observatories, we are now closer than ever to unlocking the mysteries of this colossal star. Whether you're an amateur stargazer or a professional astronomer, the eventual explosion of Betelgeuse will be one of the most thrilling cosmic events of our lifetime. So, keep your eyes on Orion's shoulder. One day, we may wake up to find that Betelgeuse has finally gone supernova.